Hello and welcome to today's presentation presented by Delubal Software. Today we'll be working in our structural analysis and design software, RFEM. The topic for today's presentation is Introduction to the new RFEM 6. My name is Amy Heilig. I'll be your presenter. I'm the CEO of the US office and also a technical support and sales engineer, and we are located in Philadelphia, Pennsylvania. I'm joined by my colleagues Alex Bacon and Siska Choa, who will be your moderators, answering any questions you may have. They are both technical support engineers, also located in our Philadelphia office. If the control panel does seem to get in your way when you logged into this GoToWebinar, feel free to show or hide that with the orange arrow up at the top. We always want to encourage everyone to ask questions throughout the presentation. You can do so within this same dialog box. If by chance we don't get to all your questions, we'll certainly send you a follow-up email afterwards. So regarding the content over the next hour today, as most of you know, we have released our new generation, which does include RFEM 6. So I want to give a little bit of background as well as where we're headed in the near future in terms of development. We'll also talk about some of the new features and improvements you can expect. And finally, we'll move into our introductory example today within the program, where I'll show you guys how to model, analyze, and design a structure. And finally, we'll talk about the improved printout report options. So RFEM 6 was released several weeks ago. It was actually developed in parallel over the past several years with RFEM 5 as well. Now, this new program generation isn't just a minor modification of RFEM 5. Actually, we have completely rewritten the program in a modern framework programming language. This is C++ with Qt. So this first release will certainly include a lot of new features, but I do want to be clear that not all of the capabilities of RFEM 5 are yet developed for this first release. And in particular, this might include glass design, cross-laminated timber, some BIM integration. So what we plan are several release phases for this ongoing development that you can expect in the coming months. What this also means is that you'll have frequent access to updates in the Delubal extranet account. So for current customers with RFEM 6 and a valid service contract, we're coming out with these updates almost weekly now because development has been so heavy and rapid with this new generation. However, we plan to fully support RFEM 5 for this 1 to 2 year overlap period. We definitely recognize that there's many users who need the capabilities for cross-laminated timber, for example. So you can continue using RFEM 5 as you would as normal. Again, we'll continue fully supporting that until those features are available in RFEM 6, then maybe you want to consider upgrading. There is forward compatibility with RFEM 5 to RFEM 6, so you can open these older models in this new version. For the most part, you're going to see a lot of the geometry, the loading carryover, but what you will now lose is the add-on module data. And the reason for this is that we have better integrated these add-ons in the main program, so there's no way to keep that compatibility between the two versions. And finally, the RFEM 6 will have a completely separate RFEM license configuration than what we see in RFEM 5. So we're moving to cloud-based licensing. And so if you plan on updating from RFEM 5 to RFEM 6, this will actually be an additional license that we'll give you without taking away your RFEM 5 license. So I'm sure there's many users who've joined us today who are existing RFEM 5 users. And I have put in here the hyperlink that will take you to our website to answer probably many of the frequently asked questions that you might have related to upgrading. This PDF is available within the GoToWebinar. You can download it under the handouts. It's also available on our website where you registered for this webinar. Now we have these standard add-ons that you would expect, such as concrete design, steel, timber, aluminum, and several others that you saw in RFEM 5, but I want to talk about a few new add-ons that we have so far. The first being the building model. So this is an add-on within RFEM to define and modify building stories. So this is to be a little bit more competitive with some of those building-only softwares out there. And for multi-level story structures, we now have the ability to define different stories. categories or levels. Where this might come into play is when we're talking about topics such as a response spectrum analysis, where we'd like to see what the story shear is at each level. So this will now organize it in a much better orientation than what we saw previously. We're also working on additional development, topics like diaphragms and center of rigidity. The optimization and cost CO2 emission estimation, this is an add-on with an RFEM to optimize models using artificial intelligence. So we can optimize elements within the program based on weight or cost, but also taking into consideration CO2 emissions. And finally, we have the time-dependent analysis. So this is the add-on to consider time-dependent material behavior of members. So we might be able to define a start date, an end date, and take into consideration topics like creep, shrinkage, or aging within the analysis. So some of the new features I wanted to highlight here. Now, this is not an exhaustive list. Again, you can visit that hyperlink at the bottom of this slide that will take you to our website. It explains many more features in detail. But to begin, we have a much better integration of the add-ons within the main program RFEM. So previously we saw in RFEM 5, we would complete the full analysis, then we can move into the design portion. Well, now we're able to do both the analysis and the design within one workflow for a much more efficient process. You'll also see the output of design formulas from the relevant standards. So we can see a nice screenshot over here on the right-hand side, and I'll show you this within the example today. But when we're designing according to the AISC or the CSA, or the ACI, then we're going to see all of the formulas listed here with the variables and the code reference and equations. So as much as RFEM 5 was very transparent, we've actually stepped this up quite a bit by giving you even more information to understand where those design ratios are coming from. Member and member set representatives will also see in today's example, this allows us to group members together. And instead of setting individual settings for each member, we can now group them together to set input such as for concrete, the reinforcement for an entire set of columns, or for beam design according to the AISC, I can set my unbraced lengths for a group of members. As I mentioned, RFEM 6 is now entirely cloud-based, so this will be much more efficient as well. You can essentially launch RFEM from any computer with your username and password data. So we'll do away with what we saw in RFEM 5 with a network versus standalone options. Now instead, you can share licenses by just sharing that username and login data. Hotkey definitions. Now, this isn't a huge improvement, but it's certainly an important one because this was a requested item over and over again. So now you can define those hotkeys on your keyboard to pull up certain tools within the program. The improved printout report, definitely some advantages here that we'll see in our example today. Very organized, very professional, as well as very powerful. The multi-core solver for a quicker calculation. We're going to take advantage now of your computer's multi-core processor. So previously we had to solve each load case and each load combination one after the other. Now we have the ability to solve multiple load cases and combinations at once. And so the model will essentially solve much, much quicker than what we previously saw. Web services and API, this is a subscription service. So this allows us to read data into and also read data out of RFEM and all of the add-ons. And this will utilize the programming languages Python and C#. So a lot of improvements there in terms of connecting to your own user-defined tools or your own website, and in terms of feeding data into and out of RFEM. Okay, so let us jump to our example today, and we are going to launch the new program version RFEM 6. So when we create a new file, we'll see here our base data dialog. We want to initially give it a model name. The type of model can also be set within these settings below. You'll see here 3D, 2D, and 1D. But one thing to note is that we do have the ability here to work in that 2D environment or that 1D environment, but you also see 3D listed here. What this means is that although you're working in that two-dimensional environment, we can consider topics like out-of-plane deflection within the analysis, for example. Under this second tab is all of the add-ons that we currently have available. Now, we still have this concept with RFEM that you would only pay for the add-ons that are relevant for your design projects. For example, if you're a company that never does aluminum design, you would never purchase the aluminum design add-on. So it keeps the software affordable and really catered to your specific materials and project types. Now, for today's example, I've turned on the concrete and the steel design add-on. Some of these others that are grayed out, this just means that they are in development and they will be released in those future phases that I discussed earlier. Under the Standards tab, because I have activated both the concrete and steel design, we now want to select our standard here. Now, this is one thing that is significantly different as well. When you purchase the steel design or when you purchase the concrete design, timber, aluminum, and so on, you now have access to all standards. So you can see here under steel, you have access to the Euro code, the American code, Canadian, Chinese, and so on. Same concept for concrete as we'll see here within the dropdown. Now the load cases and combinations, this is automatically included with the RFEM, so we can select one of the given standards here. Today we'll be utilizing the ASCE 7. Under the settings and options, this is where we would want to modify our global axes. So I'm going to orient my Z axis upward and my local axes for my members and surfaces, my local Z will be oriented upward as well. So once we have defined all of this information, we are now brought into the main program. So we have our graphical interface here. We have our tables to work with down at the bottom, our project navigator, and our tools up at the top. So a lot of similarities what we saw with the previous version. But of course, as we kind of move along today with modeling, I'm going to point out the differences as well. You'll also notice that I'm working in a white background. I think when you first install, you'll find that it's actually a black background. Under options, display properties, you can really control any of the colors, the font sizes, the element sizes within this dialog box. Down at the very bottom, you can quickly load a dark background or a white background. Also at the very bottom of the screen are our grid settings. So I can right click and edit this, and I've set my grid point spacing to 1 foot. And I've also set this to 50 feet on either side of the origin. Now, obviously, if we're working in a much smaller scale here, let's say an FEA of a connection, we'd probably want to change this to inches, which we can access our units here and set the grid point spacing to something much smaller. Our O-snap settings, our object snaps, in other words, this might be something that might be familiar in AutoCAD, where we can turn on and off all of these different snap options, such as perpendicular, parallel, quarter points, and so on. So let us begin today by creating several nodes. So I'm going to go up to my toolbar to create my first node, and I can either select any point within my drawing grid here, or I can just automatically put in the coordinates such as 0, 0, 0. I hit enter on my keyboard. That node is hidden here at the origin behind these axes, so we'll just have to trust that it's there for now. The next node will be 19.5. 30 and 0, I hit enter. We can see that generated over here. The third node is going to be negative 18.5, 15, and 0. Now, be careful not to move my mouse out of this dialog box. Otherwise, you'll see that the program will automatically sync up to where my mouse is currently located. So we input in that third node here, and we can right click to exit. So I'm going to draw my first surface, and I will go up here to my tools to create a new rectangular surface. The stiffness type is going to be set to standard. Now this is something that's a little bit different. We're now going to create a new thickness. And this thickness, if we launch this dialog box, will be set to 8 inches. And the settings here can now be assigned to any surface. So the thickness is now a property of the surface. Why this is an advantage is that we have several walls that are all 8 inches thick, and we want to quickly make changes to the thickness of all walls. We'll come in here and change the thickness type. Now I also can set the material here for my first surface. So we can visit our material library, and I can take advantage of my filters over on the left to filter to the United States. The material type will be set to concrete, and I can choose the ACI 318 2019, normal weight concrete 4,000 PSI. So now you can see that material is set here. I click OK. We can see the thickness and the material are both generated here. Now notice that there are several tabs up here at the top. This is now this new concept that the design portion is integrated within the main program. All of these tabs are specific to the reinforcement according to the ACI for this particular surface. So in reality, we'd probably want to define this input data as well. But for now, for just the sake of this example and workflow today, I'm going to turn off my design properties. I'm only concerned with the analysis right now. We'll revisit this at a later time. I click OK, and I will snap from this origin point down here to my second node, and I'm going to do the same concept for my second surface. Now I have 2 continuous surfaces here. Realistically, this is the same thing as modeling one surface, and meaning that we'll have full force transfer between these 2 surfaces. But if I wanted to clean up the model a little bit to truly create one continuous surface, I'll go ahead and use this tool to connect my lines or members. I'll highlight over this node here just to break apart this line. I select this line and I hit delete on my keyboard. So now I'm just left with the boundary lines of what will be my surface. So instead of creating a new rectangular surface, I now select my boundary lines. I do not need to redefine my thickness, my material. It's already available within these drop-down options. I turn off my design properties. I click OK to highlight the lines, and now we can see that we have one continuous surface here. I'm going to take these 3 lines located at the upper portion of this surface. I can right click to take advantage of this tool, extrude the line into a surface for my wall elements. I'm going to extrude this in the negative Z direction, 12 feet. You'll notice that my material and thickness can also be set here from my previous options. And now we have our wall options. I'm going to hold down my control key to select these 3 walls, double click to open them, and turn off the design properties for now of these wall elements as well. So notice all of those additional tabs are now gone. So now we want to move on to drawing a few members. So I'll turn off my grid settings here, and let me turn this into wireframe just so it's a little bit easier for you guys to view. I'm going to create some additional nodes where I want those columns to frame into this slab element. So we'll go back to drawing a new node, and I'll input in my dimensions manually here of 16.5, 3.5, and 0. I hit enter. I will input in my second node of 16.5, 26.5, 0. And my final third node is going to be at 0.5, 26.5, and 0. So now that we have these 3 nodes generated, I'm going to hold down my control key here, as this is where the column will be framing into the slab. I'm going to use my move copy tool, also located in my toolbar, to create one copy, negative 12 feet in the Z direction, and I click OK. So now I just have simply defined where I want the start coordinates of my columns to be at the bottom of my structure. So let us begin by drawing our first member. I can go up to my toolbar to select new single member. Now the member type is shown here within the dropdown. A beam is anything that's a typical beam or column. Of course, we have tension only, compression only, cable elements if we'd like. But for now, for this typical column, we want to choose the beam member type. Now under the second tab is the cross section. So right now we don't have any cross sections defined. I will visit my cross section library, and we can see our steel cross sections here, which will refer back to the AISC or the CSA standard. We have some parametric thin-walled and parametric massive sections. For my concrete column, I want to choose a massive square. Now, I don't need to define my material. You can see I can use the same 4,000 PSI concrete, but if by chance we were defining a steel member, for example, well, we could set a new material here by going into our material library, and over on the left, instead of concrete, we'll filter to steel, and we can choose the AISC 360. Now, here are all of my materials, such as A992, who wanted to select it, and now that material will be available to us for all of our members. But of course, this is a concrete column, so we'll stick with the 4,000 PSI. Taking a look at our second tab here, this will be where we set our dimensions. So I'm going to choose 12 inches for my cross section. Under these section values, the program will automatically update to consider the cross section values calculated automatically. So I click OK because now I have defined that cross section. You'll see the material is defined here as well. Now, going back to the main tab, again, we have all of these additional tabs that are specific to the reinforcement design for the ACI standard and that concrete add-on that we have activated. I'll turn this off for now, something, again, we'll get into a little bit later, and all of those tabs now disappear. The member is considered as fully fixed when we leave everything as default here. If we wanted to add in a moment release, we would just simply select the hinges here, and up pops a new tab where we can create a new hinge type. The program is automatically going to suggest that we'd like a moment release, so we'll release the moment about the local Y and local Z. So once we define that moment release, we can now select it at the member start and member end. Now for my concrete members, I want everything fully fixed, so I'll just go ahead and deactivate the hinges. And we're ready to snap from this bottom point up to this top point here to draw in our first column members. So I can render this and we can see those square sections framing into our slab element. Now I also want to draw a beam that spans between these two columns. So I'll come up here to draw a new member. Now the member type for this example will be beam, but we also have the options such as rib. And if we visit the second tab here, we have the ability to set the rib on the underside of that surface. We can design this as a T-beam according to the ACI standard, integrating those internal forces. For this example, I'll just keep this as a typical beam element. Remember, again, I'm going to uncheck these design properties. I do, though, under the second tab, want to create a new cross section. So I go to my section library, and instead of a square section, I'll choose a rectangular massive section, 4,000 PSI concrete, and under this second tab, I'm going to input my cross section dimensions of 10 inches by 12 inches, and I click OK. We can see that's automatically updated here. I click OK, and it's really just as easy as snapping from the top point of the left column to the top point of the right column. So we're primarily done drawing these concrete elements for this portion of the structure. What I want to do now is to add in some openings for my wall elements. And we can do this by turning back on our grid, and I want to change the orientation of this drawing grid. So you'll notice I do that with my toolbar, and now my grid is kind of oriented parallel along this middle wall. The purpose of the drawing grid is just so it confines us to this particular plane, so we're not snapping to points that are clear off in space. And this can be used for our new opening, which we can select from our toolbar here, new rectangular opening, and we just simply select a couple arbitrary points. I want to change my drawing grid now to a different plane. And I'm going to change the origin here as well with this helpful tool where I can snap to the upper left corner of my intermediate wall, and we can see now the drawing grid kind of oriented along this plane. And now I can add in my new rectangular opening, perhaps a little bit bigger than the last one, and we can see that shown here. So this just gives you a general idea of how we can model both members and surfaces within the program. Now, for the sake of time, I am going to jump to an already saved model here where I went ahead and modeled all of the steel members as well. Again, exact same process can be followed. Maybe you'll notice here a couple differences. Well, first of all, I'm displaying the cross sections according to these various colors. And we did this under the project navigator over here, and you can scroll all the way down to the bottom where we can change the colors according to the member section, for example, just for a little bit clear look at what exactly cross sections we're using. All W sections except for my cross bracing here, which you can see I defined as tension only members and single angles. Notice the hinges is grayed out here. For some of these options like tension only, compression only, we're going to assume that you have a moment release. So that's actually applied in the background. You'll also notice too that I have these main members here on the left and the right hand side with these intermediate members framing into the weak axis. And these are applied along these particular nodes. This will come into play a little bit later on when we have a discussion about unbraced lengths. So what we need to do now is to support our structure now that all of our members and surfaces are modeled. So we'll come up here to our new nodal support. And we create a new nodal support definition. We have here 6 degrees of freedom, 3 in translation, 3 in rotation. The program automatically suggests we want some type of pin support. So we will restrain translation and we will go ahead and restrain rotation about the global z-axis. Now there is the ability to define here partial fixities with a spring constant or nonlinearities as well. So for example, if you want this to support to fail and uplift, that's also possible. So defining this simple pin support, I click OK, and now I just need to highlight over the bottoms of all of my columns and to choose this column over here on the left-hand side. The line support for the bottom of the walls, exact same concept. We're going to create a new line support definition. And we can see our 6 degrees of freedom for a line support. We only need to restrain this in the translation directions. I click OK. And you can see here that I can go ahead and select my lines, and I'm going to select the bottoms of my walls. So I can graphically select those. I click OK, and now we can see the line supports at the bottom there. All right, so modeling is essentially complete. Let us move on to loading. And for this, you'll notice that I do have my drop-down box here with one default load case already defined. So let us go into the Edit Load Cases and Combinations dialog box. The first tab here references what we have already set in that base data. We are going to generate our load cases and combinations according to the ASCE7. I have activated this combination wizard here. Under the load case, the first load case defined is dead load with the action category dead according to the ASCE7. Notice self-weight is active here, -1 in the global Z direction. I'm going to create my second load case, which will be live load with the action category set to live. Notice self-weight is unchecked here because we do not want to account for it twice. And finally, my third simple load case for today will be wind load with the action category set to wind. All 3 of these load cases are set according to a first order linear analysis, which is typically fine for load cases. So then we jump to this design situations tab, and this is somewhat of a new concept within RFEM 6. So we have 2 design situations created here, our LRFD and ASD. Now we know LRFD is going to be all of our factored load combinations, and ASD is going to be all of our unfactored load combinations. You can see that I have activated these for both concrete and steel design. So this will come into play a little bit later on for the design portion of the structure. Under the load combinations, this is where we will see our load combinations individually listed out based on the load cases we've defined. So here in orange are my factored load combinations. Here in red are my unfactored load combinations. Now, all of these are run according to a second order analysis. So both big P delta and little P delta, nonlinear as well. Before we move on, there's one more topic I want to discuss. And for this, I'm going to select all of my load cases here and activate what's called the structure modification. So with this structure modification, we want to create a new definition here. And I have the ability for several options here, but I'm going to focus on the modify stiffnesses for my members and my surfaces. And now we get 2 additional tabs. Well, under the members, this is where we want to use our drop down here to define a new stiffness modification. So when you are working with either the US or the Canadian standards, concrete or steel, these are both relevant. Topics such as the I cracked factor for concrete are not by default applied to these elements. We need to come in here and tell the program, okay, let's modify the stiffness for the analysis to apply this I crack factor. So we'll select the ACI from the drop-down box. We will select our columns to apply an I crack factor of 0.7 to the bending stiffness. Well, I click OK, and then in this second cell is where I can graphically select all 3 of my columns that this I crack factor will apply to. In a similar fashion, I choose a new member stiffness type according to the ACI, but this time I want to choose beams for a different I crack factor of 0.35. For this, I am going to graphically select my beam element here. Now, the third definition is going to be related to the AISC 360. So for steel design, we know that if we are designing according to Chapter C and the direct analysis method, we need to apply this tau sub B as well as this 0.8 stiffness reduction factor to our members. So I'm not going to get too much into the details with this. We can cover these later webinars specific to steel design, for example, but we do want to apply these stiffness reduction factors for our steel members. Therefore, we will graphically select all of our steel members here. I click OK. Then under the Surfaces tab, we want to create a new definition. We're going to jump back to the ACI. And this time, we want to choose the option Walls Uncracked for a stiffness modification I cracked factor of 0.7. I click OK. And then under my surfaces, I'm going to select all of my wall elements, which there are only 3. For my second definition here, I create a new stiffness modification. This one is going to be according to the ACI. And for flat plates and flat slabs, I crack factor of 0.25. And we're going to select our only slab element here, surface number 1. So now I have applied these stiffness modifications to be considered for all 3 of these load cases. Under the load combinations, we need to highlight all elements. I activate the structure modification. I don't need to redefine. It's already available here within my dropdown. But this is important that if there's this scenario where you don't want to reduce the stiffness for serviceability, for example, well, maybe we uncheck these options for unfactored load cases. So many options there, but for now, we'll keep everything active. Okay, so now that we have defined and set up all of our load cases and load combinations, we can see these reflected here within our dropdown, and we're now finally ready to actually apply the loads to the structure. So we'll start off within our dead load, and I will apply a new surface load. So I access this tool up here in my toolbar, and the load magnitude is going to be negative 0.03. Sorry, let's change that to 0.04 kips per square foot. And this will be in the global Z direction. So I can click OK, and I just simply highlight surface number 1. I click OK, and there is that new load under dead load. For my steel members over here, I could take the process of applying a new member load to each individual element here, and that's not to be confused with line load right next to it. Line loads are relevant for surfaces. But alternatively, I'd like to define an area load and have the program distribute that to the members automatically. Under Insert Load Wizards, we have this option here, Member Loads from Area Load Wizard, and we can launch this dialog box. So same concept here. I'm going to apply a load magnitude of negative 0.04 in the global Z direction. But under the geometry tab, I have 2 options. I can either select the corner nodes graphically of this area load, or alternatively, I can let the program determine the cells in the graphics that this will apply to. What I mean by this is that the program can detect these closed cells here, which we can see them shown graphically. Now all I need to do is to highlight these cells. All of the relevant members are selected here, and I click OK. Now, for instance, if I want to remove the influence of this area load for any of these members, because we have a one-way area load distribution, I can, for example, choose member number 11, and I'm telling the program, okay, member number 11 here, I'd like to remove the influence of all members that are parallel to it. So now when I click OK, what we'll see here is our area load applied. But we can take this a step further by right-clicking and displaying separately. So now we have neglected the influence from all those members framing along the global x-axis. All the tributary areas are automatically considered, and we have our nice member area load shown here under dead load. A couple nice new features within RFEM 6. If we wanted to adjust the size, we can just simply right-click on the load, and you'll notice that that size can either increase or decrease depending on the sliding scale here. Additionally, if we add in this area load and we're thinking, oh, we really meant to apply that to live load, it's really not a problem now that we can just easily double-click on the load and change the load case within this drop-down box here. Okay, so that will wrap up dead load, and we want to move on to live load. Now for my live load, I'd like to apply a load to my surface, but not the entire surface area. So what we can take advantage of within our drop-down box up here at the top is the new free rectangular load. The free rectangular load allows me to once again specify a magnitude here of -0.1 kips per square foot. And I'm going to assign this to surface number 1. I can graphically select it. I can just type in number 1 here. And then I can choose my coordinate points of where this load should be located on the surface. Now we have the ability here to project down this load over several surfaces. So for example, if you have a multi-level story structure, the live load occurs at the same location at every single story level, then you can apply this to multiple surfaces at once, and the load will be projected down through that elevation. So for this, I'm just going to select surface number 1, and I'm going to choose my upper left corner point here and my lower right corner point here. And the coordinates are automatically updated. I click OK, and now we can see that live load applied to only a partial area of the structure. Now for my wind load, we just want to have a basic application here in the lateral Y direction. So I'll start off with a new surface load. And the surface load is going to be in the global Y direction this time with a load magnitude of 0.03 kips per square feet. I click OK, I can graphically select this surface, click OK once again, and we see our simple lateral load applied to this wall. But we might be asking ourselves, well, we're certainly going to have a window in this area that will be essentially distributing the wind load to the outer perimeter here of this surface. So how do we consider that? Well, we've also added in a new quick feature here called new opening load. So we launch this dialog box, we just simply type in the load magnitude again, 0.03 in the global Y direction. We click OK, and we can easily just click on that opening. And now we can see that load applied to the outer perimeter of that opening. In a similar fashion, let us consider that maybe in this entire open area here, we have some type of facade wall. And we didn't model the facade wall because it's not really contributing structurally to this particular model, but I'd like to consider it for wind loads. And I'd like to introduce you to a new feature that we've also added available under our surfaces option. So I'm going to go to this option here for new rectangular surface. Now, the stiffness type, instead of standard, is now going to be set to load transfer. And the surface type is exactly as the name implies. It is used to transfer loads. It does not add any stiffness to the model. You'll notice that the thickness, the material, all of these options are grayed out. It's really just a tool to be used for area load distributions. Now, if we jump to the load transfer tab, you can see here we can set either a one-way area load distribution or a two-way. So we'll set this to both directions. You can add in a surface weight. You can consider many other options here within this dialog box. So when I click OK, I am going to draw this new surface by turning on my drawing grid now. It's already oriented in the plane that I would like it. And I'm going to snap from this point at the bottom of my structure up to the top of the structure. And now we can see that new surface applied here, shown in red. Now again, I'm not adding any stiffness, material, nothing. It's really just used so that now I can go up here to my new surface load, apply a load magnitude of 0.03 in the global Y direction, just like what we saw with the previous wall before. I click OK, and I can now highlight this new surface, and we can see that load applied here. Now, if we're curious to know what's going on in the background, if we scroll up here to our navigator, and in particular, I'm under these display options. So the display options are just controlling everything that I'm seeing here visually. We can turn things on or off, or maybe change the display type settings. And one of them is under the basic objects for surfaces, we can turn on the display of the load transfer separately. So now we see these line loads that are being distributed to the structure. And we have a single vertical line load and a horizontal line load. If we decide, well, I'd really like to have one-way area load distribution, no problem. Just double click on this surface. And remember, under the load transfer, let's change this to the local Y direction instead. And I click OK. So now we see a single line load kind of oriented here towards this top slab element. Okay, so now we have defined all of our various loads. We can view them displayed together for all of these different load combinations, considering the relevant load factors. A few more things to take care of before we're ready to run that analysis and design. The first is the FE mesh settings. So under calculate, mesh settings, this is where we can choose our target length of our finite elements. You can see I've set this to 1 foot. So now when I click OK and apply the program, and it says line number 34 cannot have a line support sign. Let's go to the table here. And it says that I have a line support assigned to line 34. Let's go ahead and turn that off. Okay, so going back to calculate, mesh settings, 1 foot, we click OK and apply. And now you can see that the mesh is going to be generated here. Let me turn this into wireframe view. The program will automatically generate this mesh. It will tie it into all of the relevant openings, the nodes, the members, everything automatically for you. So everything looks quite nice here. Of course, we'd want to modify those mesh settings depending on how large or how small our elements are within our model. Okay, so now that we have addressed most everything related to the analysis, I'm going to jump now to the design. Remember, the huge advantage of these integrated add-ons is the ability to do the analysis and design together. So let us start off by going back to our base data, and I can right-click here under my base data to launch that dialog box. And under the settings and options, we have now what's called the member representatives. And you can see now we have an additional tab shown here. So what this does when I go back into RFEM, and I'll turn this into wireframe view, and also let me turn off my mesh settings to make this a little bit more clear. You'll see all of these different color codings here. Well, the program has actually grouped together, which we can also see in our navigator, members that have similar materials, cross sections, and lengths. So what does this give us the ability to do? Well, this is really helpful for the design aspect. So you'll notice I have my 3 concrete columns indicated by this red member representative. Well, if I double click on it to edit it, it brings up my member representative dialog box here. And you can see that this includes members 1 through 3. So what I'm going to do is go to these edit member settings. And if you remember way back when, we had deactivated these design properties. So let's activate those again. And we see all of our various tabs along the top here. But I am not going to change the reinforcement settings here for each individual member. Rather, when I click OK, notice my member representatives have the exact same tabs. So this allows me to set the same reinforcement for all 3 of my columns at that floor together. And if I were to make any changes, I come in here to the member representative to make those changes rather than each individual member. and every member associated with it, so for our example today, members 1 through 3 will automatically be updated. So how is this relevant? Well, let us take a look at some of these tabs here. For example, the concrete cover, we can set this to 1.5 inches. The shear reinforcement, this is where we want to initially define our material here for our rebar. So for this, we would typically need to go to our material library, and we can visit our material library here using our filters over on the left. We can set this to reinforcing steel according to the ACI, and we choose grade 60. So once this material is set within RFEM, we can now select it here for our shear reinforcement. And perhaps we'd like to use number 4s with a spacing of 0.75 feet or 9 inches. And now you can see that this nice picture updates here with our shear reinforcement. Longitudinal reinforcement, same concept. This time though, we will select a uniformly surrounding distribution here, and we're going to leave this as grade 60. We'll select 8 bars and we'll choose number 7s from our drop-down box here. And again, this picture will update automatically. So I'm not going to get too much into all of these details. Again, we'll cover this in some additional webinars where we can spend much more time on concrete design. The design configurations, this is specific to our ACI design. So we've activated that concrete add-on. Of course, we want to do design according to strength and according to serviceability. So inside of these details are all of these different settings specific to strength design according to the ACI that we can adjust, turn on or off, or maybe we don't touch them at all. The same concept for serviceability. Serviceability related to the ACI, we're going to be talking things about the crack analysis, also shrinkage and temperature for our surface, for that reinforcement, as well as deflection. So we can set our limiting deflection ratios here for our concrete elements. So once I have set this reinforcement, I can click OK, and you'll notice here that my reinforcement is now shown visually for these elements. In a very similar manner, we want to design a few of the steel members. So I am going to double click on this pink member representative, and you'll notice that this includes members 11, 12, 20, and 21. Just like what we did with the concrete columns, I'm going to go in here under my edit members. I'm going to turn back on those design properties. So now we have these additional tabs up at the top that are specific for AISC design, such as unbraced length, very important topic. But again, I am not making these changes here for each individual member. I'm going to set them within this member representative. So if we take a look at the design types here, the initial setting is the effective length. So we want to create a new effective length. Now this is unbraced lengths for weak axis buckling, strong axis buckling, lateral torsional and flexural torsional buckling. All again, very important topics. Under this second tab, the program automatically sets the nodal supports at the member end. But remember, we have these additional smaller W sections framing into the weak axis. And I want the program to automatically detect these members rather than having to manually set that unbraced length. So I can check on this intermediate nodes, and then I can graphically select member number 11. You can see, remember those smaller intermediate frames framing into the weak axis direction. The program says, okay, I see those intermediate nodes. And now I can tell it, okay, it is braced in the weak axis direction, so the local Y direction. Well, additionally, if we only had bracing at the top flange, or it was only braced at the bottom flange, we could set an eccentricity type down here at the bottom. Now by default, it will be set to both flanges braced in that weak axis direction. This was something that was available for AISC in RFEM 5, but it was not for the CSA S16 standard, but now all standards will have access to this option here. So now when we go ahead and take a look at the member after we hit OK, we're going to see those intermediate supports shown here that are going to represent the unbraced lengths. Design configurations, same thing that we saw with the concrete, but this is specific to the AISC for steel. So we go into the strength configurations, just a few settings here related to the member design for AISC, serviceability, same concept. All that we're going to see here is our limiting deflection ratios where we can set. So now when we click OK, I want to just show you guys graphically that under these display settings, I can turn on the member effective lengths under the types for steel design, and we can actually see these visually shown here. Now, if I make any changes to that member representative, these intermediate supports will automatically be updated for all 4 beams. So really important to take advantage of those member representatives rather than modeling for each individual member. Okay, so we are now finally ready to run our calculation. So I'm going to go to calculate all, and this is going to show you guys the multi-core processor where multiple load combinations are solved at once for both the concrete steel design as well as the analysis, and you can see that solves very quickly. So what we are presented here, a new tab under our navigator for our results, and we can scroll through to our different deflections for our various load cases and combinations. We've also moved all of these display settings related to the results right here within the navigator results tab as well. So for example, the deformations. If I want to turn on the members and I want to go ahead and adjust this to the sections that are colored instead rather than line elements, I can do so here. We're probably also interested in member internal forces. So for example, I can activate this. I can view my axial forces here. I can view my shear forces. Maybe I'm interested in my bending moments. But all of this information can also be shown to us in what's called a result diagram. So any one of these members, I can right click, and under the members, I have the ability here to launch the results diagrams. So this is the same information that I was just viewing. It's just in a little bit more detail along the full length of the member. I can add this information to my printout report. I can scroll through to some of the different load combinations. And something that's new within RFEM 6 is that I can drag this over to a separate monitor and I can work in RFEM at the same time, and everything will update in real time. So for example, if I change my load combination here and I instead want to take a look at my result diagram for this beam, I can jump here to my member, to my result diagram, and you'll notice that everything updates here on my second window. All right, so that will essentially just give a brief overview of our analysis. I also should mention too that of course our surface analysis information is available to us here within these different options, including internal forces. Let us talk about the design. So currently we're looking at the static analysis, but we can use this dropdown to choose the concrete design instead. So we no longer have this separate application of analysis then design. Everything is here together. Now, one thing that I wanted to actually adjust here, let us jump back to the concrete design, and I'm going to go back to the input data, and I forgot to do this to begin with. This is really, really important. Under the design situations, you can see here that my LRFD load combinations are related here to my strength design. But my unfactored ASD load combinations, remember these two design situation types, I want to actually relate this to my serviceability instead. And the program says, okay, well, wait a minute, I need to redo those results. That's fine. Notice here that seismic has also been added according to Chapter 18. So this is probably something that we will want to go in and adjust to make sure strength and serviceability are assigned to the correct design situation types. Also, under objects to design, the program will automatically default to everything. If we only want to design, let's say, those certain members within the program, let's say our 3 concrete columns here, we can graphically select them, members 1 through 3. Within my steel design, same exact concept, but I want to jump back to my input data. And under the design situations, my LRFD is going to be assigned to my strength limit state, and my unfactored ASD design situation type will be set according to my serviceability limit state design. Objects to design, I really don't want to design everything here. I mean, we can, but we haven't input in all of that information except for our 4 members here. So we're now designing these 4 members, and let us go up to calculate all again. It's already run through the analysis, so you'll see here the concrete and the steel will just quickly solve again. So now we have already discovered the static analysis results, but we're going to jump here to the concrete design. So you'll notice that my navigator updates accordingly. And I'm currently viewing all of the various design checks here, but I want to focus on this table where I can view the design ratios by member. And you'll notice here that I can automatically look at all of the various checks according to the ACI. The program syncs in the background to show me exactly where I'm at for that controlling internal force for that member. Now we can take this a step further for any one of these checks according to the ACI to launch what's called our concrete design check details. So this is what I had mentioned in the PowerPoint, where we're now going to show you all of the formulas. We're going to show you the variables. We can add this information directly to our printout report as a graphic. We also can select any one of the other checks here just to take a look at the various formulas that are really coming into play for this ultimate design ratio that we're viewing here. Now, the long-awaited interaction diagram is now also available. So I can activate this interaction diagram, and I have an additional tab here that shows the 3D interaction diagram for both axes of bending as well as the axial force. It will show you exactly the point that you land on with this particular column. Again, we can add this information to the printout report. So this was a great new feature that we have also added for concrete design. So jumping to steel design, really same concept here for viewing our results. We're currently looking at the design ratios on the members. And we can see here design ratios of members, and as we click through these, the program is showing us these 4 members, and we can see the design ratio shown along the member length. We're giving you all of the checks here related to the AISC. And again, for any of these elements, we can come here to the design check details, and just like what we saw with the concrete, we're able to see all of the formulas, the variables all listed out here. We can even expand out some of these settings to see how the member was classified: slender, non-slender, compact, non-compact, and so on. Of course, we can jump to any one of these various detail settings here for one of the other checks. So we can close out this, and notice everything is shown to us graphically here. Again, the table syncs to the navigator. What else you'll notice is that we're showing the mode shape that was used in the background to calculate the critical buckling mode for the lateral torsional buckling. So this is actually showing us our failure mode of this particular element, taking into consideration, if you remember, those intermediate supports that we previously set. So hopefully this is a nice overview of just how the analysis and the design portion can be run together within RFEM 6. Now, I know we only have a few minutes left. I want to just cover the printout report and maybe a few new options there. So up in our toolbar, we can create a new printout report here, and up pops up our printout report manager. And this gives us the ability to turn on and off all of the different input data, the results as well. And once we have this set for, what you plan to use maybe for your company, for all of your models, go ahead and come down here and save it as a template. So you don't have to set this information every time. You'll also notice that you can load a few default save templates, which will use this template number 1, the input data and reduced results for today. So when I click save and show, this will go ahead and launch our printout report. And this is going to be a completely separate application here. So you'll notice that we have all of our chapters defined over here on the left-hand side. I'm going to collapse these. I know it feels a little bit overwhelming, but we'll actually see that they're categorized in these various chapters. Now, one important thing to note is that I can actually move this printout report to a separate monitor and again, continue working in RFEM, deleting members, changing around my design, and this printout report will update within real time. All pictures, all data, so I don't have to refresh it. The program has the intelligence to update that printout report. Now, this cover, I can go ahead and right click to edit it. I can change logos, any of the information that I've seen here. What also is relevant is our pictures. We can always right click on these pictures to edit them. This will bring us back into RFEM. And if I decide, I really would like to turn off my member representatives, well, I can go ahead and do so by graphically changing that modification here. Maybe I want to turn off my FE mesh, so I'll go ahead and turn that off. And I'm going to rotate around the model. I kind of hit that too soon. Let us go back to the edit. I only just want to change the size of the window here. So I'll select these two elements here to kind of zoom in, and I'll be able to select my window that will be encompassing for that cover page. I click OK, and now we can see that this cover picture will be updated, not showing those member representatives or the FE mesh. I kind of rotated it around. So again, that's true for every picture within the printout report. If we go back to RFEM and we would like to add in our deflections as a graphic, let us jump back to the static analysis. We can turn on our global deformations here, and I'm going to zoom in. I'm really interested in printing off the global deformations for every load case and combination. Well, typically we would come up here to print the graphics to the printout report. And I might be thinking, okay, I'll do it for dead load, I'll come back in, I'll do it for live load, and so on. But let us take advantage here of some of the various settings that we have. First of all, I'm going to change the height to 50%. Also, I'm going to take advantage of what's called the multi-print. So now with the multi-print, I have additional tabs here up at the top where I can go to my results, for example, and turn on the deflections for all 15 load cases and combinations. Now when I click Save and Show, what you'll notice is that the program and the progress bar down at the bottom is going to run through each one of those load cases and combinations. And now you'll notice that all of my pictures are shown automatically here for all 15 load cases and combinations. Again, if I make any changes to the model, these pictures will automatically update. Let us turn now quickly to one other topic within printing out graphics that if I take a look at my surface up at the top and I create a visibility by this selected object and I view it in the reverse Z direction, I'm interested in this surface and the MY forces. So I go ahead and turn those on, and I also turn on the values on my surface. So these are the values at each grid point for the MY value. I'd like to print this off to my printout report as well. So if I go to print the graphics to the printout report, the problem is that if I choose the current view only, this is pretty small. I can't really see what I'm really looking at. So what we have the ability to do here is to actually scale this picture, and I can choose a scale ratio of 1 to 25. So that looks much better, but now we're missing a significant portion of the rest of the structure. We've added in this feature called tiled pictures. So now you'll notice that the program has created 6 pictures that will essentially be stitched together that we can view in our printout report so that we can view those settings a little bit closer in better detail. If I click Save and Show, we can see that the printout report automatically updates, and now we have those tiled pictures shown to us here. So that's also a beneficial feature. The final thing to just mention is inserting maybe additional pictures that you have saved to your computer or PDFs. Well, let's say under the steel design, I want to incorporate a few of the pages from the AISC 360. I can actually right click under my Steel Design chapter and I can insert an image here, or I can insert a PDF below the item. So when I choose this option, I can navigate to where I have my PDF saved of the AISC 360. And I'm going to go ahead and print off some pages there. Now, I don't have to print off the hundreds and hundreds of pages and insert them into this printout report. Rather, we'll choose pages 102 through 103. I click OK. And now you'll notice when I expand out these details, the program has automatically integrated in the PDF from the AISC 360 directly into this printout report. So this can be really helpful, again, for additional images. Maybe you have separate technical papers you'd like to incorporate, but then we can transition right back to where we were here with the steel design within RFEM. You can create new chapters, you can edit new chapters. If I want to move my steel design before my concrete design, all you need to do here is just go ahead and drag and drop. The program will automatically update. So really powerful now in terms of our printout report, and of course, many new features that will hopefully be helpful for you guys. Okay, so we want to jump back to the PowerPoint here to go ahead and conclude today's webinar. This webinar will be recorded and placed on our website where you had registered, so feel free to visit it there if you want to recall any of this information or run through it yourself. You can also download this model that I used today directly under the Delubal website as well as the PowerPoint presentation. So go ahead and visit delubal.com. Now we're also, of course, offering the free 90-day trial version for RFEM 6. So if you like what you saw today, go ahead and request that 90-day trial version directly at delubal.com as well. Our phone number and email are shown at the bottom of the screen, 267-702-2815, as well as info-us@delubal.com. This is directly to our Philadelphia office. So if you have any questions about today's presentation or anything else, feel free to contact us. We will have many more upcoming webinars. You can register at delubal.com under support and learning webinars. As most of you know, I tend to send out a reminder email about a week before these take place, so keep an eye out for that. PDH certificates will automatically be emailed to all participants today who were here for the full presentation. This is a requirement of the states where we are pre-approved providers so that you are here for that full duration. So you can expect to see those within the next day or so. If you did watch the presentation with a colleague and you yourself did not register for the webinar and you were here for the full duration, you can go ahead and request that PDH at the info-us@delubal.com email. And with that said, I want to thank everyone for attending today's presentation. And as always, we hope to see you at the next one.